Hey, welcome back. In the previous video, we have learned how to create a peer connection and create a call and an answer offer to start a connection. So we are ready to receive the other session description from the opponent. So I'll create a function called remote session received, and it will require a session description object. And using our peer connection, we will set remote local description this session, and it wants the SDP observer as well. Since we are not observing what happens, I just pass my SDP observer like this. And the other one is when we receive an addIceCandidate, we just want to add this to our peer connection like this. And one more thing, whenever our peer connection generates an addIceCandidate, we also want to send this to our opponent. So I'll create a function send addIceCandidate, get the addIceCandidate and the target. So first we want to add this to our peer connection. So let's use this function and add this first, and then using our listener we want to transfer some data to opponent. So I'll create a data model with type of data model type of addIceCandidate. The username is username, target is target, and the data is going to be the candidate, but we wanted to wrap it as a JSON like this. So the next function is how to create a screen capture. So to do that, let's scroll back up here and create a function private fun init surface view, and it will get a surface view renderer. First we want to store this surface view inside our WebRTC client, and then we want to prepare this for our peer connection. So to do that, I'll use the run block and set mirror to false, set enabled hardware scaler to true, and use init block and pass EGL based context to prepare or initialize my init surface view. And right here I'll just call it after I initialize my WebRTC clients, just like that. So whenever we create this WebRTC class, our surface is going to be ready to use. And the next function is going to be a public function, start screen capturing, and it will get a view surface view renderer. And to create a screen capture, first we want to get display metrics, and I'll create a window manager using context, get system service, and pass the context dot window service, and cast this as window manager. And after that, using default display, get metrics and pass displays metrics to it. So using this display metrics, I'll get screen width pixels dot width pixels and screen height pixels get height pixels. Okay, so right here I'll need a surface texture helper, and I'll create one using create function, and as a thread name I'll use the current thread.name, and for the context I'll just pass root or EGL based context. But right here, to create a screen capturer, I'll create a function called private fun create screen capturer, and it will return a video capturer. We will use this to capture our screen. So I'll just return screen capture Android, and we are going to need a permission result intent. So I'll create a var called permission intent of type intent, which is going to be null initially, and create a setter for it. Fun set permission intent. It will get an intent, and this dot permission intent is equal to this intent. So let's make this private. So right here we're going to need this permission intent and media projection callback. So I'll create it as an anonymous class, just like this, media projection callback. So whenever the permission to screen capture is stopped, this function will be triggered. So we'll just log it, stopped screen casting permission. So right here we will fill this permission intent later after we took it from our user. I'll create a global variable private val screen capturer of type video capturer, which is going to be null initially, and right here I'll instantiate it. Screen capturer is equal to create screen capturer. It's var not val. After this we want to initialize our screen capturer, but since we know it's not null here, so as a parameter it requires a surface texture helper, so I'll pass it the context and the capture observer. So we are going to need a local video source to use its capture observer. To create a local video source, let's make a space here. I'll write private val local video source and use it by lazy, and using peer connection factory actually I'll create a video source and pass false as a screencast. Right here local video source capture observer. After that I want to start the capture, so start capture. Let's make this non-null again. As the width I'll just pass screen width pixels, and as the height I'll use screen height pixels, and for the FPS or frame per seconds I'll just pass 15 to it. So we are ready to create our video track using this local video source. So to do that, let's go up here, create two variables. One of them is local video track of type video track, and it's going to be null initially. The other one is local stream of type media stream. It's also going to be null as well. And let's create their ID actually. Private val local track ID is going to be local underline track, and local stream ID is going to be local stream. So let's go and create those video tracks and media streams. Right here I'll instantiate my local video track using peer connection factory create video track, and as the ID I'll just use local track ID plus underline video, and as the video source we'll just use local video source. And then it's time to preview our local video track inside our local surface view renderer. So we'll use addSync and use it view to display it inside this video. And it's time to create our local stream. So I'll instantiate it like this using peer connection factory. Again, create media stream or local media stream and pass the local stream ID to it. Stream ID. And after all of this, it's time to use our peer connection and add our stream to our peer connection. So I'll use local stream to add this to my peer connection. Okay, so whenever we are the starter of the connection, we will use this function to create and screen capture and add that as the local stream to our peer connection. So we are providing to other peer. There are two more functions left. One of them is close connection function, which I'll wrap inside a try catch block. And first I want to stop capture of screen capture, then I want to dispose it, and using local stream also dispose, and using peer connection close. And the next function is restart. In that case we want to close connection first and check if our local surface view is not null. I want to clear its image, I want to release it, and I want to reinitialize my WebRTC client using username and it as surface view renderer and observer as this third argument. It's also not null, but let it be. So that's it for this video. We are ready to use our WebRTC client inside our main repository. In the next video, we'll start to create our main repository and use both of these socket clients and WebRTC clients in our project. So until the next video,